Hello everyone, welcome back to my knowledge share session. Learn with me. We are going to continue on the same topic, cloud platform integration. In the past videos, we were looking into the topic of how we are encrypting the message using a existing palettes, right? And under the security section, we were trying to encrypt the message using the existing encryption palettes. Today we are going to see the same thing, but how we are going to encrypt the message using the Groovy script. Right. So today is slightly different from what we were doing in the last sessions. Here the encryption is based on the same key, that is a symmetric approach. The previous classes we were seeing as a asymmetric approach, that sender and receiver will be having two keys, private and public, like that, right? But today we are going to see about in a symmetric approach that the sender and receiver is going to share the same secret key, which we call it as a AES, Advanced Encryption Standard, right? Plus the same thing, how we are going to encrypt the message using the Groovy script. We are not going to use any palettes here. So how we encrypt the message, that we will see it. Okay. Before that, just see that hello. Okay. Before going to the Groovy script, we have to see two important parameters in this encryption method. One is called the secret key, and other one is called the IV, right? What is AES? AES is widely adopted symmetric encryption algorithm. The term symmetric signifies that the same secret key is used for both encrypting and decrypting the data. Its strength and widespread adoption makes it convenient for modern cryptography. Okay, so AES operates on fixed size blocks of data and supports various key lengths like 128 bytes or 192 bytes or 256 bytes, etc. With a longer key, we will get a more secured encrypted data. Okay, so this is the AES which we are going to use it in our encryption method. So for that we will be using a two parameters called key and IV. So what is a key? Key is a secret key. Think of a secret key as a shared password between the sender and the receiver of the encrypted message. Only those who possess this key can unlock or decrypt the data. In the context of CPI, it is absolutely crucial to manage this key in a secured way, ideally using the CPI secure parameters, or you store it in a Keystore. We never embed the secret key directly with the Groovy script or send it along with the message. Okay. Then what is the IV? IV is called initialization vector. This is like a random number. So adding a randomness to the encryption. So this IV is a random value used to ensure that even if you encrypt the same piece of data multiple times with the same secret key, the result will be different. Right? Without an IV, encrypting identical data with the same key would always produce the same encrypted text. This predictable pattern could be exploited by the attackers to potentially touch your data, right? So IV introduces an element of randomness, making an encryption process significantly more secure way. Okay, that's it. So We are going to use the Groovy script, which will encrypt your data using a AES algorithm, which will be using the secret key and IV. That we will see it now. Okay.
Okay, now I am inside the online Groovy editor. First we will test the Groovy script here in the online Groovy editor, and then we will move it to iFlow and implement the same script. Okay, so the online Groovy editor is we already explained in one of my previous videos, which is called ide.contiva.com, ide.contiva.com, which will simulate your CPI environment where you can push your message, push your headers and properties, and using the Groovy script you can test your output of your Groovy script. Okay, using this same editor I will test my Groovy script, which it's going to encrypt your incoming payload. Okay, this is my Groovy script, and what I am going to do is I will open up my what is the message I am going to use it. Okay, this is the incoming message JSON. I am going to encrypt it. Okay, so the JSON file will be looking like this, which is a name and account. This is this message I am going to encrypt it. I will copy paste my Groovy script and explain you one by one. So I will copy my Groovy script. I will also paste my Groovy script in my description column so that you can use it. Okay, so I copied it, and now I will explain you one by one. So these things you will be knowing. These are all the applicable import packages which I am going to import it in my Groovy script. And this Groovy function will start like this. Very first step, I will read my body to a variable called JSON. Okay, this probably you might be knowing all these things. Now the second step is, I told you I have to create one secret key and one IV, right? Two things I have to do it. As I explained you, in AES I have a key and an IV. IV is very important, that every time you encrypt the same message, it will produce a different output. Without IV, then it will give you the same encrypted message so that anybody can interrupt it. The second step is generating a key, secret key. So using this one of the package, the key generator, this package, I am going to generate one instance. I am going to use the method, the algorithm called AES. There are multiple things are there, but we are going to use AES here. So using this AES, and the key length is, I define it as a 128. Right. The more key length, the more security will be there, but for the demonstration purpose I use 128. And the secret key, now it will generate the secret key, the keygen.generate. So a key will be generated, and that key will be converted as a bytes using a encoding. Right. So I need the value in a bytes. So my first part, key is generated. Now second thing is generation of IV. So this is, IV is nothing but a random number. So it will create a new random number, and that I will convert it as a byte again and store it in a variable called IV bytes. So key bytes and IV bytes are the two parameters which I am going to use it for the encryption. Now fourth step is the actual encryption. So these are all the syntaxes for encrypting it. The appropriate packages you can refer it back in the import statements. Okay, so to create on a cipher object. So PKS padding is Padding is nothing but when you are dividing your text, you are converting your text and you are dividing your text in 128 bits kind of things. Suppose the last block is not having enough, then you are going to pad with some spaces or some characters. So that is called PCKS padding. So effectively the whole text will be divided into a defined number of blocks, and each block will be having a 128 bytes. Okay, so these are all the steps to encrypt it. So finally encrypted message will be stored as a encrypted bytes, right? Finally then I will convert this encrypted bytes to a string, and then I will store it in a variable called encrypted in base 64. So the encrypted bytes which are in bits format will be converted into a string, right? And what are the keys and IV I am going to use it? I am going to store it in a variable because the same will be used at time of a decryption. So we need to store it somewhere else. That we will see how we are going to store it in the decryption. So right now, so we generated a key, we encrypted it, and we are going to keep these parameters, key parameter and IV parameter, in a variable called key base 64 and IV base 64. Okay, finally the body is set back to a encrypted message, and I am going to this is only for demonstration purpose, because then in a real-time process we are not going to send this key in a message. This will be communicated to the receiver in a different way, not through the message. But for just for demonstration purpose, I put it in a header properties so that we can see that and understand it. Right? That's all. Then finally return the message. Okay. Now we will execute this and we will see how output is coming. So I will execute it. See, now the output has come. So the whole message will be in a encrypted form. So no one can understand what is there inside it. So this is how we will be encrypting the incoming payload using a Groovy script. Now what we'll do is we will go to the CPI and iFlow and create a Groovy script palette and execute the same thing. Okay, now I am inside the iFlow. I will go to the package and I am going to create a new iFlow. I will create a new iFlow, integration flow. So I will say demo encrypt. Okay. Encrypt using Groovy. Add it. So I will edit it now. Very simple. I will create one palette called Groovy script. So my initial template will come that I don't want now. I will remove it. I will copy paste my script which I tested here. Okay. So this is the script. I use it. I copy paste it. Okay. So I will recap it. So these are all the import statements. So first I convert my body to a JSON and generate the AES keys, my two parameters, right? Key and IV bytes. Key bytes and IV bytes are the step 2 and step 3. and fourth one is the actual encryption. Actual encryption will use these two parameters using the AES algorithm, and which will divide this your payload into 128 bytes, blocks of 128 bytes, and the last block, which is the remaining spaces, will be using the PC key as padding. So this is the encryption logic, which you can get the details from the Google for what is the encryption logic, etc. like that. Okay. Finally, the encrypted code will be converted back to string and put it back in the message. And the parameters which we used it for encryption, called key and IV, which we should preserve it, because during the decryption, the receiver side, he has to use this same key. So how we are communicating this to a receiver side will be a different part, which we should not send it along with the message. Just for demonstration purpose, I put it here. Okay. Once the receiver receives this message, how we are going to store it in a secure parameter in the CPI, and how to access those things, we will see it in upcoming videos. Okay, in this video we focus just create a key and encrypt the message. Okay, that's all. Now I will apply it. So share some warnings, meanings. It is using one import package which is not used, so just ignore it. Okay, we are not going to, because I am not going to create any JSON file, so we can remove that also, but leave it now. Okay, close it. That's all. Now we will send a message, and this is my message. I will simulate it now. Start simulation, end simulation. In this start simulation, I am going to pass my content, and I will simulate it. Now simulation is successfully completed. Okay. Now we will see that. So the beginning of the thing, there is no properties, there is no headers, and body will be what I am sending it. After the Groovy script, see the headers is having these two parameters, which is, I call it as a key and IV. So this is the IV, this is the key, and this is the IV. This is a vector, and this is the secret key. So these two things we have to communicate to the receiver side. That we will see in the next video, how we are going to communicate, and we are storing it in a secure place. Okay. So there are no properties, and body will be in the encrypted form. Okay. Hope you got this video got the idea of how we are going to encrypt the message using the Groovy script, and what is the AES, and what is secret key, and what is IV, etc. Okay. That's it. You can try the. I will put this Groovy script in my description. You can try it in your own way. In the coming videos, what we'll do is we will see how we are going to store this store these parameters in the CPI, and how we are going to retrieve it from the CPI. For that will be used in the decryption process. Okay. So in upcoming videos, I will show you the remaining steps. Okay, these steps we completed with the encryption method. Okay. Hope this will be helpful to you, and please update your comments, please update your questions in the comment section. the more comments and more questions, I will be very happy to answer it. Okay, thank you so much. Thank you for watching.